Okay, good day, good people. Let us look at dynamics and work. Just take the recap of dynamic and continue with it. Sorry for taking forever. Let us look at the definition of dynamics. Dynamics is the branch of mechanics concerned with motion. Dynamics, it is concerned with motion of bodies under the action of forces. It deals with the cause of motion, meaning it looks at the cause, what causes a body to move from point A to point B. Now, from the definition, you get to understand that the cause of motion, it is what? It is forces. Now, let us look at the definition of a force. A force, it is defined as the influence which changes or attempts to change the state of rest or the constant movement in a straight line of an object. Yes, I would agree with you saying force is a pull or push, but for now, can we stick with this definition because it makes more sense? It is the influence which changes or attempts to change the state of rest, meaning when an object it is at rest, then there's an applied force on that object. The object will start to move, meaning now the force, it is the influencer. It influences the object to move from point A to point B. That's what it means, and it makes more sense. Now, force, it's a vector. Force, it's a vector. What is it that we know about the vector? We know that vector, it's a quantity that has two things, magnitude and direction. Yeah, it has two things, magnitude and direction. We will be working with this principle of force being what? Being a vector. Now, all forces going up, they are positive, as you can see on this diagram. And the force going up, it is known as your normal force. Like I said, that it could be plus or minus, depending, because it's being associated with what? With the wind. Then the force that goes to the western side, it is negative. Now, that force, it is said to be what? A frictional force. Yeah? Then the force that goes to the east, it is positive, and it is said to be the force applied or force acceleration. Then the downward force, it is called the gravitational force, or FW, meaning the W from the mass or weight, meaning the bigger the mass, the greater the gravitational force, or the greater the friction, that's the W from. Now, your dynamics, it is governed by laws of motion, because when you look into the laws of motion, you will actually understand more about about forces. The laws of motion are Newton's laws, and it is Newton's first law, Newton's second law, and Newton's third law. You need to know those laws, and you need to know how to apply them. Newton's first law says an object remain at rest or continue to move in a straight line with uniform velocity unless acted upon by an unbalanced force. Now, when an unbalanced force acts on an object, it will either come to rest or it will cause an object to move. That's what it says. Therefore, you need to know it, and you need to know how to apply it. Now, Newton's second law says the rate of change in the momentum of an object is proportional to and in the direction of the applied force. Like I said, you can either use this definition or you can use Newton's first law and continue to say the object will take the direction of the applied force, like they are saying here, in the direction of the applied force. You can say an object remain at rest or continue to move in a constant speed, not unless an unbalance or an external force act on it. Then the object will take the direction of the applied force. You can use that one as well. There's nothing wrong with it. They will give you full marks. And then Newton's third law says for every action there is an equal and opposite reaction. This one, it is static at its best, or you can say some of the clockwise forces equals to some of the anti-clockwise forces. This Newton's third law, it says it all. This are Newton laws here. I've tried to write them for you here. Yeah? Please go through them and know them. Now, you can't talk motion and not talk formulas of motion, because forces, they occur as a result of what? Of motion. Motion occurs as a result of a force. Yeah? Now, how do we then calculate the force? Force, it is, how do we calculate the force? Because these are formulas of motion. How do we calculate the force? Force equals to mass multiplied by acceleration. Where must we take the acceleration? From these formulas. These are formulas of motion that would help us to calculate the force behind motion. Yeah? These formulas will help us to calculate the force behind the motion. Now, we will be using those formulas to calculate whatever that they want us to calculate. Now, please don't forget that we will be using this principle here. All forces going up, positive; forces going down, negative; east, positive; west, negative. Now, let's apply this principle, more especially this principle here. This principle I just stated. Let's apply it. I have two questions. The first one says a car with a mass of 1000 kg is moving at. Now let's take out the data, the given information regarding number A. Let's look at number A for now. A car with a mass, we are given a mass. The mass of the car, it is 1000. We are taking out the data. Now let's not write it and just highlight it, because it's a given information there. We are having the mass. Here's the mass. We are given the mass, it is 1000. We are given the velocity. It's in kilometers per hour. We therefore have to convert it to meters per second. How are we going to do that? It's going to say 80 divided by 3,6. 3,6 equals to 80 divided by 3.6. It is 22. It will give you 22,22 meters per second. Now this 3,2, it is one and the same thing as 3,600. How did we get 3,600? Remember, K, it's 1,000. That means it will be 80. It will be 80,000. You write 3 zeros. Per, that per, it is divided by hours to second. We know that 1 hour to minute. We know that 1 hour to minute, 1 hour to minute, we need to multiply by 60. We need to multiply by 60. Then minute to second, we need to multiply another. We need to multiply by another 60. Then we would have converted an hour to seconds, and it will give you 60 multiplied by 60. I mean, it is 6 multiplied by 6. Come on, now it is 36. Now it will give you what? 3,600. That is why instead of using 3,600 to do all this conversion, you just have to say 80 divided by 3,6. Then you will get this answer here. Instead of doing all this conversion and say 80,000 divided by 3,600. Because 60 multiplied by 60 will give you 3,000. Instead of doing this conversion here that I just did here, you can somewhere say 80 divided by 3.6, then you will still get the correct answer. That's the information that we have. Then we are having the displacement as well. We are given the displacement, it is 45. They want us to calculate, the first question, they want us to calculate the deacceleration. The deacceleration will use the formulas of motion like I indicated. We will be using one of those formulas based on the given data. You don't just pick up a formula, you check the data that it is given. If the formulas that you have, they suit the data, then you will select one of the formulas to the formula that suits the given data. In this case, the given data, it is suited by first formula number 1. Now let's go to the given equation there. Right. They want us to calculate the deacceleration. We'll use formula number 1 based on how I wrote them. It is v squared u squared plus 2as. Do I have v? Yes, I do have v, and my v in this case, it is 0. Right, because when you read the given statement, they are saying a car with a mass of 1000 kg is moving at. It is moving at. Now, that's your initial velocity. This 80 kilometers per hour, it's your initial velocity. What is your VV? It is your final velocity. But in this case, we are given what? The initial velocity. Now, it will be, do I have the initial velocity? Yes, I do have. It is 22, 2 squared. Plus, do I have... I'm looking forward for A. Now I need to make A the subject of the formula. Do I have displacement? Yes, I do have. It is 45. I do have. It is 45. Therefore, in making A the subject of the formula, you will transpose this 22 to the left hand side. Then you will have A equals to 0 squared minus 22, 2 squared, divide by 90, because 2 multiplied by 45, it will give you 90. That's what you will have here. Then your A would be 22,22 squared divided by 90 equals to 4 equals to 5. Our answer is 5, 4, 8, 5 meters per second squared. Meters per second squared. Right, but it's a negative answer because 0 minus 22 squared, it will be a minus answer. Our answer there is negative. Right, our answer there is negative. Right, our answer there is negative 4,585. We managed to calculate the deacceleration. We can therefore use this deacceleration to calculate what? To calculate the force behind the motion. The force behind what? The motion that took place. A horizontal plane is, braked to a state of rest over 45. You can tell that the car was in motion. A car with a mass of, it was in motion. Then we can therefore understand the force that brought the car to rest. Now, in calculating, this is what we have. In calculating, we calculated the deacceleration. This is your deacceleration. Then, now they want us to calculate the braking force. Now, the force that brought this car to rest, it will be FB equals to MA. Our A, it is this one. Our mass, it is given. There it is. Now it will be your answer. It will be 1000 multiplied by MA. 1000 multiplied by the calculated deacceleration multiplied by negative 5,485. Then our answer would be, what would be our answer there? 5,000. 5,000. 5, it will be 5,483. 85, I mean to say, not 3. Yes, 5,485. It is negative 5,485 newtons. No. Right, we therefore managed to now check the value of this force. It is negative, giving you the picture that it is that force which opposes the applied motion. Which forces are considered to be the forces which are opposing motion? All forces which are negative forces based on their direction, they are opposing motion. Frictional force, it opposes motion. Ne? FW, it opposes motion. Braking force, it will be same side with your frictional force FB. It will be here. It's a negative force. It's heading same direction as. It's a force that opposes what? That opposes motion. Hence the answer there, it is negative. You can tell based on the given principle here that all forces going up are positive and forces going down are negative. You can tell. We applied exactly those principles. Let us look at the second question, and you can tell the first question and the second question, it is the same thing. Ne? They just changed the values. This time around we are given the resistance to motion, meaning it is your frictional force. Now let's take out the data, the given information. A vehicle is traveling on a horizontal road at 90 kilometers per hour. We therefore have to convert it to meters per second. Now V, it will be 90 divided by 3.6. 90 divided by 3.6. Let's see. It will give us what? 90 divided by 3.6. It gave us 25. It gives us 25 meters per second. Right, we are sorted with that one. Eh? Then we are given the mass as well. We are given the mass, it is 2000 kg. We are given the frictional force. This time we are given the frictional force. Our frictional force, it is what? It is 600 newtons. Right. And what else? Oh, we are given the displacement as well. We are given S, it is 75 when the brakes are applied. Now we are told that there's a braking force that was applied. Ne? Now they want us to calculate the deacceleration. Now in calculating the deacceleration, again, we'll go back to the given, we'll go back to our formulas and look at the formula that suits our data. Now the formula that suits our data, it will be the first one. Like I said, it is the same thing. It will be the first one. The first one suits our data very well. Now we are having V squared equals to your U squared plus 2AS. Right. We are looking forward for A. Now A would be, our A would be V squared minus U squared. Minus U squared divided by 2S. Now check this. Let's analyze the given information properly so as to understand why V is 0. It is because of the given statement says a vehicle is traveling on a horizontal road at. Already this car is in motion. Ne? You can't say that's your final velocity. That's your initial velocity. That is the speed at which, ne? Or the speed that we are introduced, the first speed that we are introduced to. Now, if the statement continued to say the driver accelerated to, now the car moved from 90 to 120 kilometers per hour. Now the V2, now the V2, or rather that 120 would be the V for final. That's the one that you are going to use. You're going to say 120 minus 90 if we were given that statement. But in this case, this is what it's given. The initial velocity is 90 there, of which we have converted it to be 25. Now I'm having 0 squared minus 25 squared. 25 squared divide by 2 times 75. Times 75. Let's get our answer. Right. We are having 25 squared divided by 2 times 75. Now our answer, it is 4, 167, let's say 7 meters per second squared. But remember, it's a deacceleration, it's a negative force. From how we used our formula, our answer, it's going to be what? To be negative 0 minus 25. It is negative 25. That's our answer there. We managed to calculate the deacceleration. Now, the second question is that they want us to calculate the braking force. Now, let's give you the schematic of that, the given information there. That's what we have here. We are having the force applied. Force applied in this case, we will calculate it. The force applied, it's a reduced force as a result of the braking as a result of the brakes being applied. Now the force applied here would be 2000 multiplied by negative 4,167. Right. Now, why the force applied? Now, this indicates to us that the force, it's been, remember they said the car, it is slowing down, it came to rest. They said the vehicle, they are saying here, please check here, they are saying the vehicle stops over a distance, meaning when the brakes are applied, meaning the force applied, it was gradually being reduced until the vehicle came to rest. It was gradually what? Reduced. Hence, we will take that deacceleration, the A that we have calculated, and put it on the force applied. Because as the car was moving, you can imagine driving 120 kilometers per hour. Then when you look 75 meters ahead, there's traffic cops. You will obviously reduce the speed, bit by bit until the force comes to rest. Now you can tell that the force applied at that scenario or at that moment, it is what? A reduced force, or it is a force which has been reduced, or it is the force which was gradually being reduced. The force applied being gradually reduced. Now we are having three types of forces. We are having three types of forces, more especially on the force applied. Which can, when they are applied, for instance, in this case, we are having a gradually reduced forces. Then we are having a shocking force. Then we are having a normal force. Now we are having three types of the application of those forces, but unfortunately it is not the scope of our syllabus on science and theory. But we are having that. We are having the gradually applied force. We are having the shocking force, and we are having, I think the third one is the normal one, but I will check for it. But we are having three ways of applying the force. One of them, it is this one, gradually reduced. Now gradually being reduced, slowed down. Then here we are having frictional force. We are having the frictional force. And our frictional force, it is given. It is what? It is given as 600 newtons. It is given as 600 newtons. Then we are looking for FB, because FB and the frictional force, they are always hitting the same side, eh? They are always an opposing. This is what we have. They want us to calculate this FB. Now in calculating the FB, it will be FA. It will be FA, or you can say total force, equals to frictional force, plus we are dealing with the grouping. Hence I wrote plus sign there just to indicate that we are dealing with grouping. This is just the grouping, because they are doing what? Same thing. But in this case, we want what? This one. Then we will transpose this force to the other side. Transposing this force to the other side. Oh, I didn't finish calculating my FA. It is 4,1167 multiplied by 2000. Right, we are having We are having 8,000. We are having 8,000. 8,000. We are having 8,304 newtons. 4 newton. Yeah. Remember, it's a gradually reduced force. It's a force applied but gradually being reduced. It's a gradually being what? Gradually being reduced. Yeah? That's what we have there. Yeah. Then here, remember, we're having minus force minus FB. Right. Now I've applied the principle correctly. I didn't group them so that you don't get confused. Then we are having negative. The fact that I've used negative here for the force applied, as in like how I applied it, being the gradually reduced force or gradually applied force. Né? It is 3, 3, 4. Now we are looking for FB. When you are taking this frictional force to the other side, it will be positive. Now you'll be having negative FB equals to negative 8,334 plus 600. The 600 it is given. Then your answer would be 7,000. Your answer would be 7,734 newtons. Boom. That's what we have here. Boom. That's your answer. Now, you can either use it this way. Now, you can either use it this way, as I've explained, that the applied force, it is the gradually reducing force. Or you can write it as a positive sign. If you're writing it as a positive sign here, you know that here it is FA. Now, everything here, it will be positive. Everything here, it will be positive if you are writing it in a positive way, like I indicated. Yeah? If you're writing it, it doesn't matter how you look at it. The thing is, knowing too much principles, it's a tata. Here it was going to be a positive, né? Because we've used the force applied as a positive. Now it is 8,344. What is frictional force? Frictional force, it is 600. When you're transposing it to the other side, the sign will change. It will be minus. Then it will give you your answer as 7,700. It doesn't matter how you look at it or how you apply it. If, like I've applied, the way I've applied it from onset, I've used other principles of your forces, that we are having a shocking force. Now when you are dealing with the shocking applied force, that means there the force, it is twice the normal force, because it is out of shock. But like I said, it is not the scope of but the one that I just given to you now, it will help you throughout your dynamic, the gradually reducing force. This is how we apply this principle here about forces. This is how good people we apply the whole thing. Thank you, good people. I will be dropping more videos regarding your dynamics.